Hello, hello. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in the Databricks playlist, and in this particular video we are going to cover the documentation. So from this video now on, what we'll be doing is that we will be reading the documentation provided by the Databricks developers, and we will try to understand each and every concept from the documentation also. So what this will give us the advantage is, first of all, you guys will understand how we can read a documentation. Secondly, if you are trying to learn anything else apart from maybe Databricks, or even if in future versions, if there is something else that comes into picture and gets added to the documentation, you guys can very easily read and learn by yourself. So in this particular playlist, we have covered Spark from the very basics till the advanced concepts. So if I talk about what all things we have covered in this particular playlist, so right from how we can read a table, right, till covering how we can rename a column. Okay. Then moving forward, what we have covered is uh, filter operations, right? Then we have covered uh, group by operations, sortings, right? If I scroll further down, we have also covered order by, how we can use the distinct function, right? And we have covered much more concepts, right? Group by we have already covered, as I told you, right? Then we have also covered how we can rename a column with group by, right? What all aggregation operations are, right? Then we have covered how we can write our data frame to a table, how we can perform filtration operation. Then when an otherwise operation in Spark, something equivalent to the if else part, right? Then talking about, we have done the join operations, how many different types of joins are there, how they are different from each other, and all these stuffs. Then we have covered the window functions, how many different types of window functions are there, what exactly every window function is required for, all types of window functions we have covered, right? Then once done with this, we have covered uh, like even the partition by clause. Okay. And then we have covered UDFs, how we can create our own UDF. Then if I scroll further down, so what is pivoting we have covered, how we can use aggregation functions in pivot we have covered, right? Then we have covered our dbutil modules, what exactly dbutils is, how many different type of modules are present in dbutils. It may be file system, it may be widgets, right, notebooks and whatnot. Then we have covered uh, difference between the global temp view and the local temp view. We have already covered what is replace temp view, and if what happens if we don't use any kind of replace temp views thing, we have covered. Then we have talked about the JSON file formats. We have covered single line JSON files, as well as we have also covered the nested JSON file formats. Then we read about what is started, committed, and success file. Then we have covered how we can create schemas depending on the table. Then how we can create multiple table using one single line of code dynamically we can do. Then we have talked about how we can populate uh, synthetic data using Nemesis, that is a library. Then how we can optimally know if our data frame is empty or not, right? And then we have covered that how we can use delta tables to get the history of our tables. So all in all, if I talk about this particular playlist, so around we have covered around 40-45 videos till now, right? And we have covered from the very basics till the advanced topics, like uh, talking about how we can fill the null values, JSON file, handling the JSON file formats, and much more topics that we have talked about right now. So if you are someone who is trying to learn Spark from the very basics or just want to cover the advanced concept, this particular playlist can be very, very helpful for you guys, right? So moving on, right now, what we will be doing is we will jump straight to the documentation of Databricks. Okay. So the very first thing that Databricks tells us about is the Delta Lakehouse. So we have already covered Delta Lakehouse in, I guess, the second or the third video of the playlist. There I have explained about the Lakehouse architecture. But here let's understand it from the developer's perspective, because obviously they are the ones who have created this technology, the Databricks people, right? So they will be letting us know much more things that we are maybe already aware about. Cool. So let's understand what is a data lakehouse. So a data lakehouse is a data management system that combines the benefits of data lake and data warehouses. So the very first line, we are very well aware about this particular thing, that the name lakehouse itself came from the I would say the addition of lake, data lake and the data warehouse thing, right? So this article describes that the lakehouse architectural pattern and what can you do on what can you do with it on Databricks. So here we will be understanding that what exactly the lakehouse architecture is and how we can utilize or maybe take advantage of that particular architecture and what all things can be performed in the Databricks. Okay, so this is what we will be learning, or this is our goal is. So just understanding the image itself, right? So we are already aware about that in data engineering, or I would say in the modern days, right? In the modern data architecture, we can have multiple data sources and even the type of data can be different. So we can have structured data, something like this. So this is a structured data, right? Then we can have the unstructured data, something like this. If we have some kind of image and all these stuffs, so we can have the unstructured data. Here we have some kind of maybe connectors or the data may be coming from cloud, right? Then we can have videos, again a kind of unstructured data. Then we can have the binary file formats also. Okay, so these are binary file formats. These can be something as, let's say, maybe a Parquet file format, Avro, and all these kind of file formats are there for the binary purposes. Okay. Now the data from these data stores will be stored in some kind of object storage. Okay, so there can be one single object storage or there can be multiple object storages depending on our requirement, right? From here, like from the object storage, the data will be pushed to the bronze layer. So here the raw data, absolute raw data is getting stored. So this is the bronze layer of our data. Let me take my writing pad so that I can, or let it be. I guess that's fine. Okay. So this is the bronze, because all these things obviously I'm letting you know, so even if the writing is not that good, you guys are able to understand, right, that this is the bronze layer, right? And in bronze layer the data will be absolutely raw. There will be no kind of transformation that will be done in the bronze layer. Then moving forward from bronze layer to the silver layer, so this is the silver layer of data, silver layer. Here some kind of transformations are done. Maybe we can handle the null values, right? Some kind of validation checks can be there. The schema validation and all those stuffs can be there, right? And all these things can be performed in the silver layer. Maybe some kind of joining of tables and all these stuffs can be performed in the joins, and all these things can be performed while transitioning the data from bronze layer to silver layer. So silver layer is, I would say, a moderately clean data. Okay, not very clean, but a moderately clean data compared to the bronze level. Then from the silver layer, we will be transforming the data again to the layer, something called as gold layer. Okay. This is the gold layer data. So gold layer data usually have some kind of business transformations done on the silver layer. Okay. It means what kind of data do we require at that particular period of time or for that particular use case. That particular kind of transformation is done while transforming the data from silver layer to the gold layer, right? It may be something, if I give you an example, right? So let's say we are having multiple departments, right? We have sales department, right? We have marketing department in our organization. Okay. Then we can have, let's say, an HR department, finance department, and all these things, right? Obviously, IT department will also be there, right? We have multiple departments. So the data requirement of all these departments will be different from each other. It's not that we can just give a single file or maybe a single table access. Okay. We can give this single table access to all the departments. Obviously, that will not work in this particular way. How it will work is, in our silver layer, we will be having the data. Then we will be transforming the data for every department based on its requirement, and we will be storing it into the gold layer, right? So this may be for my let's say sales, right? This may be for my finance, right? This may be for my marketing. Okay. Because from the base data, there can be some rows only, or I won't say some rows, only some columns that will be required for the sales data, and maybe the join of two different tables. For the finance team, it may be a join of other two different tables that is more helpful in getting the insight that they require. Cool. So I hope you guys are getting my point, right? That based on the requirement, we will be doing this transformation from silver layer to the gold layer. Okay. And once the data is into the delta table of the gold layer, it will be then connected to some kind of data mart, maybe for the BI purpose, right? It may be some connected to some kind of feature store for maybe doing some kind of machine learning model training and all these stuffs. Maybe it may be displayed on some kind of application, right? Or maybe some kind of development sandboxes uh, can be spin up on top of this particular data. So it solely depends on the requirement and the business that we are following. Okay. So and on top of all these things, and like if you look closely at this particular diagram, so you will see this Unity catalog that is responsible for handling the data governance. So it governs the data in our Databricks. So right from the bronze layer, right from the bronze layer till the gold layer, bronze, silver, and gold, my Unity catalog will be storing each and everything in its meta store, and that will be again like it will create a kind of graph, or I would say a lineage, where we can easily maybe do some kind of data versioning, right? If we require, we can follow what all steps were followed to get to this particular state of the data. So all these things can will be governed and will be handled by that thing, something called as the Unity catalog. Okay, cool. Let's move forward. So even if you did not understand a few bits of things, don't worry. Moving forward, each and everything will get cleared. Okay. So it's not that you have to understand each and everything in this particular video only. No, we will be again moving forward. We'll be like discussing much more things in much more advance. Okay, there each and every concept will get clear. Then what is a data lakehouse used for? Okay, so a data lakehouse provides scalable storage and processing capabilities for modern organizations that want to avoid isolated system for processing different workload like machine learning and BI, that is business intelligence. Okay. So what data lake or the what advantage data lake provides to the organizations is it will first of all provide a scalable storage. Scalable storage means like regardless of the volume of the data that you are dealing with, it may be it may be a few hundreds of GBs till a few maybe hundreds of TBs or maybe a petabyte of data. Okay, data lakehouse will work with all the volume of data, depends on what kind of data that we as an organization have with us, right? So for even for the storage and processing capabilities, lakehouse will not have any kind of difficulty processing any volume of data for the organizations. Okay, and want to avoid isolated system for processing different workload like BI and ML. Okay, so what this particular thing means, so this means that earlier what used to happen is, so let's suppose if I am an organization, so I will have some kind of workload like this, or I won't say workload, some data pipeline like this, that this is my maybe a data lake, right, that we have. Okay, this is the data lake that we have right now. From this data lake we will be having our pipelines. So the very first thing, again we will be storing like doing some kind of transformation on this raw data, and then we will be storing this particular data on this table. Okay, again we will have some kind of, let's say we have a data warehouse here, we have done some kind of transformation, right, and we have stored data in this data warehouse, right? Then maybe we can connect some kind of Power BI tool or reporting tool here, right? And we can train some kind of, like we can have some kind of feature store, and using this feature store we can train our machine learning model. So you can see that we have different pipelines, right? Here also there will be some kind of data replication that will happen, right? We will have some kind of technological overhead, means we will have to manage two pipelines here, right? This is one pipeline and this is the second pipeline. So we have to manage two pipelines from the scratch, right from writing the transformation till storing data, till creating the feature store, training the machine learning model for the first pipeline, and for the second pipeline doing the transformation, again storing it in some kind of data warehouse, then connecting it to some kind of BI tool, right? So instead of this, what Databricks did is, from the same source you can do this, you can create your maybe the data, the transformed data. Okay, I won't name it any kind of layer. Whatever data is transformed, again you can connect your feature store and you can train your machine learning model right from here, and from the same store you can connect your BI tool. So this is how Databricks changed the modern data pipeline architecture, I would say, and again saving tons of money for the organizations. Okay, a data lakehouse can help establish a single source of truth, as I already told you, right? So here this will be the single source of truth. Okay, this data store is the single source of truth that will eliminate the redundant cost, right? Earlier, as we had multiple data sources, so obviously we will be incurring multiple cost, right? Like multiple cost, right, for multiple data storages, and which also ensures the data freshness, right? So obviously if any kind of data is getting added, it will get added to this particular feature store only. Like, it means the data will be freshness, means the data will be I would say in a good stage, I would say, or I can say that it is well organized data. Okay, well organized data and well governed data we will have in this particular store. Okay, so it means it will have a good data freshness. Okay, it will be a rich data. Then data lakehouse often uses a design pattern that incrementally improves, enriches, and refines data as it moves through layers of staging and transformation, which we have already talked about in this particular diagram, right? That here we will have a raw data doing some kind of transformation, it will be changed to the silver layer data from the bronze layer, then again doing some kind of transformation, the bronze layer data will be changed to the gold layer of data. Okay, then each layer of lakehouse can include one or more layers. This pattern is frequently referred to as Medallion architecture. For more information, see this. So let's understand now that what exactly this Medallion Lakehouse architecture is. So if I open this link, let me delete this line. Okay. So what is a Medallion Lakehouse architecture? So the Medallion architecture describes a series of data layers that denote the quality of the data stored in the lakehouse. Okay. So ultimately what matters is the quality of the data that we are producing or we are having as an organization. Okay, because that only will help me later on to do some kind of visualization or doing the machine learning aspect of it, right? Databricks recommends taking a multi-layered approach to build a single source of truth for the enterprise data product. So what this multi-layered approach is, we will very soon get to know moving forward in this architecture itself. Okay. So this architecture guarantees atomicity, consistency, isolation, and durability, right? So these are the properties of what? These are the properties of the SQL databases, right? The structured databases, which provides us with something called as, we have already talked about, the acid properties, right? So these are the acid properties that data process uh, through multiple layers of validations and transformation after being stored in the output in a layout optimized for efficient analytics. Okay. The term bronze, that is raw, silver, that is validated, and gold, that is enriched, describes the quality of the data in each of these layers. Okay. Talked about the same thing we have talked about in that particular diagram, right? That we have seen in the lake house architecture. Cool. Let me scroll down. So Medallion architecture as a data design pattern. So a Medallion architecture is a data design pattern used to organize the data logically. Okay. Just understand this term, that it is used to organize the data logically. It means whatever the data or the transformation that we will be doing from the bronze layer to the silver layer will have some kind of logic behind it. It's not that we will be randomly doing some kind of transformations, right? Its goal is to incrementally, so that logic will is what, and the goal of the transformation is what, is to incrementally and progressively improve the structure and the quality of the data as it flows through each layer of the architecture. So as already talked about, that when we will move forward in the layer, right, from bronze to silver layer and from silver to gold layer, the structure and the quality of the data will improve from every layer. Okay, from bronze to silver and from silver to gold layer tables. Okay, the data will get improved. Medallion architecture are sometimes also referred to as multi-hop architecture. So again, you can maybe remember this or keep in your mind, because these terms may be asked in the interview. Maybe the interviewer can ask, okay, are you aware about the multi-hop architecture? So even if you are aware about this particular concept, right, that is from like data traveling from bronze to silver to gold, and the quality and the structure of the data improving, but you may not be able to answer because you are not aware about that this is the only thing that is called as multi-hop architecture or maybe the Medallion architecture, right? So these things can be sometimes handy when you are preparing or taking an interview. So you need to remember and keep these things in your mind. Okay. Again, by progressing through these layers, organization can incrementally improve data quality and reliability, making it more suitable for business intelligence and machine learning applications. Sorry. So as we are already aware about this fact that, like, if like depending on the quality of the data and the reliability of the data, we can perform a good analytics and we can train a good machine learning model. Everything depends on the quality and the reliability of the data. Following the Medallion architecture, a recommended best practice, but not a requirement. Okay. Again, following this particular architecture, like the Databricks people themselves are saying that it is a good practice. It's not mandatory to follow this particular pipeline that you have to first of all create a bronze layer, then the silver layer, then the gold layer. It's not so. It's just a good practice where you can create a different layers and do some kind of transformations, and you can include the required people in the respected layer. So let's understand this, what I'm trying to say. So what happens in this layer? Bronze layer, raw data is ingested. Okay, who are the intended users? So here the data, like the people or the team that will be I would say involved in this particular layer will be the data engineers, operations, and the compliance and the audit team. Okay, so it will be the job of the data engineers to transform this bronze level data or the raw data to some kind of like to enrich, right, to validate and to transform it into a data that can be later on utilized by the data analytics team or the data science team for doing their job. Then in silver layer, we will be doing the data cleaning and the validation part, right? Here again, data engineers will be involved. Data analytics analyst will also be involved. Use the silver layer for a more refined data set that still retains detailed information necessary for in-depth analysis. Okay, and data scientists build models and perform advanced analytics, right? So in the silver layer, usually the data cleaning and the data validation happens, right? So again, the volume of the data will be large in the silver layer. Why? Because in the silver layer, we have not performed any kind of business transformations, right? Any kind of specific transformation we have not done in the silver layer. So we will have a large volume of data. So if we want to do in-depth analysis, right, so that can be done using the silver layer data. If I talk about the gold level or the gold layer of data, so here a dimensional modeling and aggregation happens. Means the table will be joining, right? Maybe only the required columns. Dimensions means the columns that we are having. So here in the silver layer, we may have hundreds of columns, but in the gold layer, we will have only the required columns that are there, right? So dimensional modeling, it means there will be some kind of dimension reduction only in the from silver to gold. Okay. So again, dimension reduction means that we will be dropping the unnecessary columns that is not required for that particular purpose. So here data analytics and BI developers comes into picture, data scientists and ML engineers comes into picture, executive and decision makers. Okay, executive, like the top level authorities are dealing with the gold level of data. Okay, they won't be interested in the raw data, right? How we are ingesting the data, how we are storing the data, right? What kind of validations are we running? All these things won't bother the top level executive or the decision makers of the organization. The decision is made using the gold level of the data. So again, this is one of the most important level of the data that we have in any of the organization, right? Because the decision makers, the executives and everyone is working on this level of data only, and the operations team again will be working on this level of data. Now this diagram will, I guess, clear every concept and if any kind of maybe confusion that you are having, it will be cleared using this diagram that we have. Okay, so this example of Medallion architecture shows bronze, silver and gold level layer for use of a business operation team. Each layer is stored in a different schema and different schema of operations catalog. Okay, so here you will see catalog remains the same. Just like currently we have the workspace catalog, right? The name of our catalog is workspace. That's what we do, right? Workspace dot default, that is our schema. Then dot table name, maybe the life table name or the life expectancy table name, whatever table name, like whatever table that we want to work upon, right? So talking about this particular diagram, right? So as we are already aware about this fact that we can have multiple data sources with us. We can have some kind of cloud storage, right? We can have, if we have some kind of streaming data, we will have some kind of Kafka, right? So type of data, if I talk about, so we have batch data, okay, and we have streaming data. These are the two varieties of the data that we deal with. Okay, so batch data is nothing but the files and the tables that we deal with, right? Something as CSV data, JSON data, right? the binary file formats and all these things, they are nothing but batch data. Okay. Streaming data are the data that we get in very small interval of time, right? The data, if we are getting data in, let's say, some kind of microseconds or some kind of seconds of interval, in that case that data is called as streaming data. So let's say if you are using Google Maps, right? When we are using Google Maps, so Google Map is streaming the data to the Google servers, and in the real time we get everything, right? That from, let's say, 50 meters you have to take the left turn. So if it is not a streaming data, if it is not streaming our location, so like Google Maps is streaming the coordinates of our device, whatever device we are working, like we are running the maps on, every microseconds, I would say, not even seconds, every microsecond, because if even if there is a delay of maybe a few seconds only, we can miss the turn, we may go ahead of the turn, right? So every microseconds Google Maps is sending the data to the Google servers, and depending on that we are getting the path and all those things. So it is not that simple, I would say. It is much more complex thing, right? I am just explaining this thing in a few lines so that you can understand what exactly the streaming data is, right? Again, if I talk about a transaction, let's say if you are doing the UPI transaction, those transactions are happening in real time, right? So we have our bank and we are sending it to, like, person A is sending some money to person B. So what bank will do is, first of all, bank will check that, okay, if the amount that you are sending is, you have that amount in your bank or not, right? Once you have that amount, it will be authenticated using the PIN. Once the PIN is correct, it will transfer that amount to B, right? The amount will be debited from you, and the amount will be credited to B's account, right? And all these things. So all these things happen within a fraction of seconds, or I will say within a few seconds, right? So this is a streaming thing, right? So these are the two kinds of data that we handle. So for handling the streaming aspect, we have to use Kafka. And moving forward in this playlist also, we will be covering how we can deal with the streaming data also. Till now, we have covered only the batch data. Okay. Then we have Salesforce. Again, Salesforce is a CRM tool that we have, like one of the most famous CRM tools that we have for the organizations. Okay. Then from cloud storage, we are ingesting the customers' raw data. Okay. From Kafka, we are ingesting the transactions data. From Salesforce, we are ingesting accounts data, opportunities data, and the leads data. Okay. And we are dumping this raw data. We are aware about the fact that as it is, we are dumping the data into the bronze layer. We don't have any kind, like we have not done any kind of transformation here. Okay. Then we perform some kind of transformation while moving the data from bronze layer to silver layer. We are performing the transformation everywhere. Okay. We are performing transformation. Okay. So this raw data now has become, this customers raw is now become customers cleaned. Okay. Maybe we have handled the null values. We may have deleted the null values, or maybe we have filled our null values, right? We have done our validation checks, right? And all these things are done. Again, this transactions raw has become transactions cleaned. Again, this accounts raw has become cleaned, right? The raw data now is cleaned data. Okay. Then what we have done is, we have joined two tables, that is the transaction table and the customer table. We have performed the join operation, right? And the table has now become customer underscore transactions. Similarly, we have performed join operation on accounts and opportunities table, and accounts opportunities table is now the table that we will be working on, and leads table is right now as it is. Now in the gold level, again here in this level, we performed the business transformation, I would say. Okay. The business level transformation, that what exactly do we need from our data? So this table can have multiple columns, right? It can have our customer details, maybe the customer user ID, customer first name, customer last name, right? When the customer created its account, right? Maybe the purchase history, the amount of that, then that what all transactions have they done, what was the last transaction they did, the status of their transactions, and all these details, right? These can have multiple columns uh, like in them. Similarly, these accounts underscore opportunity table will again have multiple columns present inside it. But now we only require the specific thing. Okay, we only require the specific thing. So now we require what the customer is spending. So we will do some kind of filter operation, some kind of maybe again some kind of join operation, ordering operation, and all these stuffs will be done right on the customer underscore transaction, and we will create a table as customer spending. Okay, again this accounts opportunities table will go through some kind of business transformation, and accounts performance table is created, and this leads table is now as sales pipeline summary. Okay, and again combining this customer spending and account performance, we have created a table as a business summary, which will have a very detailed and very specific to the point information about each and every customer of the business what we are doing. Okay, so this table is the table that will be a kind of decision making table, or the table which top level executives will be dealing with. Okay, so we can attach some kind of BI tool here, and we can show them the insights. Okay, so this is how the data will be transformed, or this is how the journey will be of the data from the bronze level or the raw level to a table that the top executives will be using for taking the business decision. Okay, now let me delete it and let's read what the developer themselves are saying. Okay, talking about the bronze level. Okay, so bronze layer, we will ingest raw data from cloud, Kafka, and Salesforce. No data cleanup and validation is performed here. Okay, we are just dumping the raw data. Then silver layer, data cleanup and validation is performed in this layer. What kind of data cleanup and validation? Let's understand. Data about customer and transactions is cleaned by dropping null values. Okay, quarantining invalid records. Okay, there may be a situation where a record may be invalid, a row may be invalid, right? Maybe it does not have the user ID. Okay, there can be a situation that a record is not having any kind of user ID, right? Maybe it does not have any kind of transaction associated with it, and many more things can happen, right? So we will be maybe dropping those rows, right? Or what we can do is maybe we can fill those rows. We have already seen how we can drop the null values and we can fill our null values. We have already seen about this thing in the playlist. Okay, these data sets are joined to new data set called as customer underscore transaction. So a new table is created by joining these two tables, that is the customer table and the transaction table. Okay, then data scientist can use this data set for predictive analysis. Okay, so this table can be used for maybe training the machine learning model and all these things by the data science team. Similarly, accounts and opportunities data set from Salesforce are joined to create account underscore opportunities table, which is enhanced information with the which is enhanced with account information. So account information maybe when did the user last log in, how much time did they spend on our application, when account was created, what is maybe what kind of things the user searches, and all those stuffs can be stored in the account and opportunities table. Then we have the raw leads, which is again passed through the transformation steps, and the leads cleaned table is created. Now talking about the gold level. So this layer is designed for business users. Okay, it contains fewer data sets than bronze and silver layer, as already talked about, right? It will contain fewer rows and fewer data set. Why? Because it will be passed through the business logic and the business transformation that will be done from silver to the gold layer. Okay, now customer spending, this table that is created. So why this table is created? Average and total spend for each customer. Account performance, what is the daily performance of each account, that will be uh, performed, like that will be stored here, right? Then sales pipeline summary, information about end-to-end sales pipeline, and the business summary, highly aggregated information for the executive staff. Okay. Again, combining the customer spending and the account performance, we created the business summary, and this was the table that was uh, like using which the business executives or the top level authorities of the organization were taking the business decision. Okay. Again, ingest raw data to bronze layer. It's saying the same thing, that the bronze layer contains raw unvalidated data ingested in the bronze layer typically has the following characteristics: contains and maintains the raw state of the data source in the original format change and all these things will not be done in the bronze layer, is appended incrementally and grows over time. Okay, so as the data comes in, it gets appended to the bronze layer data. Is intended for consumption by workload that enrich data for silver table, not for access by analyst and data scientist. Okay, so it is just intended to be used. Okay, to be used to create the table for the silver layer data. Okay, it is not to be used by the data analyst and the data scientist, because the data will be absolutely raw. Okay, serves as a single source of truth, preserving the data fidelity. Okay, so this will be the single source of truth, right? If you require the data for any purpose, you will have to access the bronze layer data. Enables reprocessing and auditing by retaining all the history. Okay, if any kind of transformation is done, any kind of schema change, right? Maybe dropping of columns, dropping of null values, all those stuffs, whatever reprocessing and pre-processing is done, each and everything will be retained as a history, and we can like go back into the time or go back to the versions, and we can see how we landed up to that particular point from the past. Okay, can be any combination of streaming and batch data from source, including cloud object like from S3, GCS, that is Google Cloud Storage, and ADLS, that is of Azure. Okay, messaging bus may be Kafka, AWS, Kinesis, etc., and federal systems like Lakehouse Federation. Okay, then limit data cleanup or validation. So minimal data validation is performed in the bronze layer to ensure against dropped data. Databricks recommend storing most of fields as string, variant, or binary to protect against unexpected schema changes. Okay, metadata columns might be added, such as the provenance and source of data. Okay, so what Databricks itself recommend is that you should store the fields in the either the string format, variant format, or some kind of binary format, so that moving forward, even if the schema is getting changed, you don't have to unexpectedly deal with it. Validate and dedupe the data in the silver layer. So data cleanup and validation is performed in silver layer. We are already aware about this fact. To build a silver layer, read the data from one or more bronze layer or silver layer table to write the data to silver layer tables. Okay, we are either reading the data from the bronze layer, or we can also read the data from one of the silver layer tables and perform some kind of maybe join operations, group by operations, and any kind of operations, and again write the data to the silver layer table itself. Okay, Databricks does not recommend writing silver layer table directly from ingestion. Okay, a very important line that you need to keep in mind, that Databricks does not recommend writing silver layer tables directly from ingesting, right? Directly you should not perform the transformation from the ingestion only. You have to first of all store it into the bronze level, and then you can store it and perform the transformation and store it in the silver layer. If you write directly from ingestion, you will introduce failure due to schema changes or corrupt records in the data sources. Okay, so this is the reason that Databricks recommends not to do that particular thing, that is directly from you are doing directly the transformation from your source. because if any kind of schema change happens, right, maybe a corrupt record comes into play, then your pipeline will fail. So to avoid this failure, pipeline failure, you go ahead with the medallion architecture, that is storing from bronze to silver. Assuming all sources are append only, configure most reads from bronze as streaming reads. Batch reads should be resolved from small data set, for example, small dimensional table. Okay, and all these things. So I hope these things are again getting repeated, right? And you have already understood about the fact. Okay. Again, ensure data quality. Schema enforcement will be done in the silver layer. Handling and of null and missing values will be done. Data deduplication will happen. It means if the data is duplicated, so deduplication will happen. Uh, Resolution of out of order and late arriving data issues. Okay, data quality checks and enforcement, schema evolution, typecasting, joins, and all these things will be done in the silver layer. Again, data modeling and all these things will be done in the silver layer. Then power analytics with the gold layer. So we are already aware about the fact that if any kind of analytics needs to be performed on our data set, it will be performed in the gold layer. So gold layer represents highly refined views of the data that deliver downstream analytics, dashboards, machine learning, and applications. Okay. So if any kind of analytics that needs to be performed, any kind of dashboard that needs to be created on the data set, machine learning model needs to be trained, or maybe it needs to be passed on to some kind of application, these things will be done only from the gold layer, not even from the silver layer of the medallion architecture. Gold layer data is often highly aggregated, filter, and specific time period and geographic locations. Okay. So the data from the silver layer will be filtered, maybe based on the time period, maybe based on the geographic locations, right, based on the business requirement, and all those steps. After filtering the data from the silver layer, it will be stored to the bronze layer. It contains semantically it contains semantically meaningful data that map to business functions and needs. Okay. So whatever our business will require, that kind of data only we will be storing in the gold layer. Consist of aggregated data tailored for analytics and reporting, right? Aligns the business logic and requirements, is optimized from performance in queries and dashboards. Okay. Again, it aligns to the business requirement. Create aggregated tailor analytics and reporting from the gold layer. Cool. So I hope you are now very well aware about the Medallion Lakehouse architecture that Databricks follows. Let's now go back to the documentation. Okay. Now, how does the Databricks Lakehouse work? Okay, so Databricks is built on top of Apache Spark. Okay, Apache Spark enables a massively scalable engine that runs the compute resources decoupled from storage. Okay, so what this particular line means, that Apache Spark enables a massive scalable engine that runs on compute storages decoupled from storage. It means if I talk about the Spark architecture, so Spark is only responsible for processing of the data. Spark is not responsible for storing the data. So we don't store data in Spark. Storage is not there in Spark. Okay. For storing, we have something called as file systems. So we can have maybe DBFS, that is Databricks file system. We can have HDFS, that is Hadoop file system. We can have some kind of object storage, maybe S3, maybe Blob, right? And any of these we can have, right? On top of this file system, we will have our Spark running that will do the transformation. Okay. So Spark is only and only responsible for transforming and doing the processing of the data. It's not responsible for storing the data. Okay, you need to keep this thing in your mind. Even if I go to this particular link, right? So, okay, I guess you will not be able to get it here. If I go and search for Spark, Spark file system architecture. Okay. If I go to images and if I open any of the image, let's say if I open this image, okay, and if I open it in a new tab, so you can see right here. So you can see these Yarn, Mesos, Docker Cloud. These are nothing but the resource managers. Okay, it will manage our cluster. So this is our Spark cluster. Okay, so this Spark cluster will be managed by the resource managers, and the Spark cluster will communicate with the file system. Okay, so the data will be stored here. The data storage part is handled by this layer and not by this layer. Here the processing of the data happens. Okay, so this is the architecture of the Spark. Okay, if I close this, right, you can open any of the file, like not any of the one. Here also you can see if I open this image, right, here also you can see there is a distributed file system. Then there are the cluster managers. That was nothing but the Yarn, Mesos and all those stuffs. Then on top of it, there was the Spark, and these are the Spark libraries that we have. We can use Spark SQL, MLlib for doing the machine learning part, and the GraphX if we want to deal with the graphical data. Cool. Now if I talk about the, okay, so now I guess you have understood this. Now the Databricks Lakehouse uses two additional key technologies. Okay, the first technology is Delta Lake. So Delta Lake is an optimized data storage that supports ACID transaction and schema enforcement. Okay, so using the Delta Lake itself, okay, Databricks provides us the ACID transaction properties and the schema enforcement in the data lakehouse architecture. And there is something called as a Unity catalog. So a unified fine-grained governance solution for data and AI. Okay, so it's the responsibility of Unity catalog to govern and to manage the data, to do the data governance part of it, and to enforce the data governance. It is the responsibility of the Unity catalog, which we have already seen in this particular diagram also. Okay, now again if I talk about the data ingestion, so in data ingestion layer, both batch and streaming data arrives from a variety of sources and in variety of formats. Okay, so we are already aware about that there can be variety of sources. Variety of format means it can be maybe a CSV file, maybe a JSON file, maybe a Parquet file, maybe some kind of streaming data can come into picture, maybe a Excel file can come into picture, right, and all these stuffs. Okay, this first logical layer provides us a place for the data to land in a raw format. That is the bronze layer. Okay, as you convert those files to Delta tables, you can use the schema enforcement capabilities of Delta Lake to check the missing and unexpected data. Right. So as we convert the bronze layer to silver layer, we can do the schema enforcement and check for the missing values and whatnot. You can use Unity catalog to register tables according to the data governance model and require data isolation boundaries. Okay, Unity catalog allows you to track the lineage of your data as it is transformed and refined, as well as applied to the data governance model to keep the sensitive and private data secure. Okay, so to enforce the data governance, the unified data governance model, and to keep your sensitive data secure, Unity catalog plays all the role for doing that particular part. Cool. Now we talk about the data processing, curation and the integration part. So once verified, you can start curating and refining your data, right? So once the data is verified, it means the data validation part is done. We can start curating and refining the data. Means we can Curating means maybe we can perform the join operations, right, and merging and all those things. And refining the data again means maybe filling up the null values and all those stuffs can be done. Data scientists and machine learning practitioners frequently work with the data at this stage to start combining and creating new features and complete the data cleaning part. Okay, so the data science team will come into picture in this particular phase, where they will start combining the data according to the data that they require to train the model, right? Creating new features, maybe creating new features means maybe creating new columns by doing some kind of operations on the current columns that we are having. Just like we created our, if I go back here and we created that, what we call uh, GDP, right? GDP per capita, the column that we created, right? So that was a kind of feature that we created. So our raw data, it was not having that particular feature, right? But based on the requirement, okay, we can wait. It allows us, right? If I scroll a bit down, okay, it was done in the table validation one itself. A bit more. Right, so here you can see that we created this GDP per capita column by our own. So this is what we can say that we have done. What we have created a new feature or a new column, and whatever data cleaning requires to be done, it can be done again. Once your data has been thoroughly cleansed, it can be integrated and recognized into tables designed to meet the particular business needs. Okay, so this is right now, the data is right now in the silver layer. Okay, and once it is thoroughly cleaned, right, it can be integrated and reorganized into the further table, that is the gold level of data. On a schema on write approach combined with the delta schema evaluation capabilities means you can make the changes to this layer without necessarily rewriting the downstream logic that serves your end users. It means, if I talk about again here, when we were trying to write this particular transformed data frame into the table that we were already having, we got something as schema mismatch detected, right? Schema mismatch error was there. So we had to alter the table, like we had to make the schema compatible with the data frame that we wanted to store, and then again we were able to store the data. So what here, but here if you read it fully, so here we have an option of merge schema. Okay, so if we do merge schema equals to true, then the data bricks will automatically handle the schema evolution, I would say, and we will not have to necessarily change each and everything based on this particular based on the particular evolution of the schema to the downstream system also. It can only happen in that particular table or in that particular point of time only. Okay, then data serving, the final layer serves clean enriched data to be used by the end users. The final table should be designed to serve the data for all use cases. A unified data governance model means it can track the data lineage back to the single source of truth. Okay, data layout optimized for different tasks, allowing the users to access the data for machine learning application, data engineering, and business intelligence and reporting. Okay, it means that, okay, let me come with the pen. It means that the gold layer data that we are having, okay, let me represent it by the yellow color. Okay, the gold level data that we are having, so this layer of data will be like will have some kind of trail behind it, right? It will have some kind of silver layer data associated with it, right? And this silver layer data will have some kind of bronze layer data associated with it, right? So the data governance that we are writing, the data governance model that we are creating should have this lineage graph, okay, associated with it, so that whenever required we can trace this particular lineage and we can get back to the source of truth or to the raw data that we were having. Okay, so this is what the data governance thing, that is using the unity catalog, the data governance model should, like, is expected if we talk about the medallion architecture. So this is what is expected. It's not mandatory, again I am saying it, it's not mandatory, but it's expected to do this in this way. Okay, now if I talk about the capabilities of the lakehouse architecture, again I guess same thing will get repeated. So a lakehouse built on Databricks replaces the current dependency on data lake and data warehouse for modern data companies. So these are the key performance that include. So we can perform real-time data processing, so the streaming data in real time for immediate analysis and action. Okay, data integration, unify your data in a single system to enable collaboration, establish a single source of truth for your organization. Okay, again you need not move to and forth from multiple platform. This is the only single platform that you can use for doing all your data requirement needs. Okay, schema evolution, modify data schema over time to adapt changing business needs without disrupting the existing pipelines. Okay, so even if your schema is getting changed, we can modify the data schema and we can adapt to that particular schema change without disrupting, or without, I would say, disturbing the existing pipeline that we are having. Then the data transformation, using Apache Spark and Delta Lake, we can do the data transformation uh, in a speedy way, right? In a scalable way and also in a reliable way using Apache Spark and Delta Lake. Talking about the analytics and reporting, so we can run complex analytical query with the engine optimized for data warehouse workload. So in the same environment, we can do the analytics and reporting part also. We can also train the machine learning model. So apply advanced analytics technique to all your data. Use ML to enrich your data and support your workload. Data versioning and lineage. Again, the versioning and history is maintained. We can also add Git facility. Like we also have the facility to attach Git to the notebook that we have, so that we can also maintain the version of the code, as well as we can also maintain the version of the data set. The same thing that we have seen in this particular video, in the very last video that we have, right? Using Delta table. Then we have the data governance. So use a single unified system to access control to your data and perform audits. Then the data sharing, facilitate collaboration by allowing and sharing the curated data set, reports and insights across team. Operation analytics, monitor data quality matrices, data modeling matrices and drift using the data quality monitoring. So this data quality monitoring is only accessible if you are going ahead with the paid version. It's not accessible in the free version, else I would have showed you that how we can even perform the data quality monitoring. Okay. Now, if I talk about the difference between lakehouse, data lake and data warehouse. So data warehouse performs the business is like data warehouse has powered business intelligence decision for about 30 years, having developed a set of design guidelines for systems controlling the flow of data. Okay. So data warehouse is usually used for connecting to the business intelligence tools and providing the business decisions. Enterprise data warehouse optimize queries for BI reportings, but can take few minutes to few hours to generate the report. Designed for data that unlikely changed with high frequency. Okay. So if the schema of the data is rapidly changing, in that particular case, data warehouse can sometimes fail. Okay. Data warehouses seek to prevent conflict between concurrently running queries. Many data warehouses rely on proprietary formats, which often limit the support of machine learning. So in simple terms, it means that data warehousing does not support the machine learning part of the data pipeline. Data warehousing on Databricks leverages the capabilities of data lakehouse and the Databricks SQL. Okay. So again, Databricks, as we are already aware about that, it follows the lakehouse architecture. So the data warehouse that we have in the Databricks environment, we can do all of these stuffs that we can manage if the schema of the data is changing frequently, as well as we can also do the machine learning and the data science part of the data domain. Okay. Then powered by technological advancement in data storage driven by exponential increase in the type and volume of data lake can come into widespread use over the last decade. Okay. So data lake can be used to store any volume and any type of data. It can be unstructured, semi-structured, structured data. Right? We can use the data lake to store that data and to dump that data. Data lake stores and process data cheaply and efficiently. Data lakes are often defined in opposition to warehouse. A data warehouse delivers clean structured data for BI analytics, while a data lake permanently and cheaply stores the data of any nature of for any format. Okay. So we have already talked about this, that the data lake can store any format of data in a very cheap and efficient way. But this is also one of the drawback, that if the data is not governed properly, right? If the data validation and data governance is not done properly, this data lake can change into a data swarm. Means the quality of the data can rapidly decrease if the volume of the data is increasing on a in a rapid way. Okay. Many organizations use data lake for data science and machine learning and not for BI because of the unvalidated nature. Okay. Obviously, because we are just dumping the raw data here. So for data science, it can be used because we can again pre-process our data. We can do the feature engineering part, right? We can do the data validation part, and then we can train the machine learning model. But for BI part, data lake can't be used. So to overcome this, lakehouse came into picture, assembling or combining the properties of both of the data storage system, that is the data warehouse and the data lake. So again, data lakehouse combines the benefits of data lake and data warehouse and provides open and direct access to stored data in the standard format, indexing protocol optimized for machine learning and data science, low query latency, and high reliability for BI and analytics service. Okay. So everything one of the things or everything can be performed using the lakehouse architecture, right from machine learning and data science to the BI and analytics part of it. Okay. So by combining an optimized metadata layer for the validation, okay, stored in standard format in cloud data storage, the data lakehouse allows us to work from the same data in the same platform for different use cases. Okay. So again, right, there is a single source of truth and a single platform, and using that we can, based on our requirement and our use case, we can use that particular thing differently in the same platform. Okay. So this was it, and this was pretty much it about the lakehouse architecture, and I would say the Medallion lakehouse architecture that Databricks follows. Cool. So I hope you learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye.